Hello dear students, today we'll see problems on binomial distribution. In the previous class we have seen the problems on binomial distribution. Here also we'll see the problems based on binomial but in little bit different way. In 800 families with 5 children, each how many family would be expected to have 3 boys, second one 5 boys, 5 girls, third one either 2 or 3 boys, fourth one at most 2 girls, by assuming probability for boys and girl to be equal. So this 3 boys is from out of 5 children, this 5 girls out of 5, either 2 or 3 boys means from this only it is. So remember the value of small n will be out here 5, and value of 800 families means this belongs to capital N. Now just see here, so we have this problem is based on either boy or girl, means we have two faces. So therefore probability of having boy is nothing but what here 1 by 2, and similarly probability of having girl is nothing but what here again 1 by 2. So here I want to fix a random variable. So x denote the number of boys, means this x belongs to number of success from this experiment. So x I am denoting number of boys in the family. So always whenever we'll use the value of small x, we'll see that it should be what here boy only. Now as per the binomial distribution, it is given by ncx p raised to x q raised to n minus x. So we know that n is nothing but what here 5, because they have said 5 children, means the value of n is 5 cx, value of p is 1 by 2, that is probability of boys 1 by 2 raised to x, and q belongs to what here a probability of girl, that is 1 by 2 raised to 5 minus x. Since we need to find 800 families, so therefore I am going to write function of f, that is f of x is equal to 800 into p of x, and we know the value of p of x as 800 into 5cx 1 by 2 raised to x 1 by 2 raised to 5 minus x. So in this formula we'll apply the values of 3 boys, 5 girls, and either 2 or 3 boys or at most 2 girls, and we'll see the respective result out of 800. Now the first one 3 boys means we know that x is, we are going to consider what we have considered for x is nothing but a number of boys. So 3 boys means x is equal to 3. So replace, we know the formula for capital f of x is nothing but what here 800 into 5cx 1 by 2 raised to x 1 by 2 raised to 5 minus x. So x is 3 means 5c3 1 by 2 raised to 3 1 by 2 raised to 5 minus 3. So if you simplify this, you will get what here 250. Similarly, so therefore expected number of family with 3 boys out of 800 is how much here 250. Similarly second question 5 girls, but remember I had taken x as what here number of boys. So out of 5 children, if 5 girls only, so here at that time what happens, no boys. No boys means x is equal to 0. So therefore if you replace x is equal to 0 in this expression, we will get 25. So expected number of family with 5 girls is how many here out of 825 families. Third one either 2 or 3 boys. So I means out of 5 2 or 3 boys. So at that time here x may be 2 or x may be 3. So therefore here because of or, it will become f of 2 plus f of 3, which will be, so here you apply the value of x as 2, so we'll get 800 into 5c2 1 by 2 raised to 2 1 by 2 raised to 5 minus 2. Similarly for f of 3 it will become 800 into 5c3, 1 by 2 raised to 3, 1 by 2 raised to 5 minus 3. So on simplification, first result will get 250, second result also will get 250. So 250 will get what here 500. So therefore expected number of families with either 2 or 3 boys are how many here? 500. Now fourth option, at most 2 girls. At most means out of 5 children, at most means maximum 2, minimum maybe 0, maybe 1, and means 0 girl, 1 girl, or 2 girl maximum. So out of 5 maybe no girl, one option. Second option is 1 girl and remaining are boys. Third option is what here? 2 girl and remaining are boys here. So total we need to see that it should be 5. So first option is what here? If x is equal to 5, we know that x is nothing but number of boys. If x is equal to 5 means number of boys are 5, at that time 0 girl. So one condition. X is equal to 4 means 4 boys 1 girl, means 4 plus 1 is 5 only. 5 plus 0 is 5. Next 3 boys 2 girl. So we can go for at most what here? 0, 1 or 2. We cannot cross 2. So maximum is 2, minimum is what here? 0. So we have 3 options. So therefore f of 5 plus f of 4 plus f of 3, f of 5 plus f of 4 plus f of 3. So result of f of 5 is 25. Next is 125 and f of 3 is 250. So final simplification is 400. So therefore expected number of families with at most 2 girl is 400. Next question is 5 dice were thrown 96 times and the number of times an odd number actually turned out in the experiment is given. Means here it is given. So 1 or 3 or 5 means on the top of the die we may get 1 or we may get 3 or we may get 5. Fit a binomial distribution to this data and calculate the expected frequencies. So here that they have given the table. So when you throw a dice, 5 dice, so we'll may get 1, 3 or 5, and these are the expected outcomes for the given number of dice with respect to what here their frequencies. So here, so first we need to find the probability. We know that binomial distribution means in binomial distribution p of x they have given as ncx, p raised to x, q raised to n minus x. So we need to find the value of n, p, q first, then later we'll see what is the values of x and we have to simplify. Now so first n is how many here? N is 5 because 5 dice they are throwing. So n is how much here? So here n is 5. Next p. P stands for what here? P is nothing but, it is nothing but number of dice showing showing 1 or 3 or 5. So it will be what here? If 1 is coming means out of 6 only, 3 is coming means 1 out of 6 only, 5 is coming means out of 6 only. So therefore it will be what here? 3 by 6, which is nothing but what here? 1 by 2. So therefore I can say that p value is 1 by 2 and q is nothing but what here? 1 minus p, that is 1 minus 1 by 2. So it will become 1 by 2. So we got p value, q value now. So therefore our p of x will become 5 cx because n value is 5 cx. P is what here? 0.5 I will take because 1 by 2 is 0.5 raised to x. Q value is also 0.5 raised to 5 minus x. So we'll keep this formula and we need to go for further. Means these are the observed frequencies what they have given the table. So we need to work out for a theoretical frequency. So by this is by experiment, and what happens with a theoretical frequency we need to check by using the binomial here. So now since this 5 dice were thrown in the question, they have given this 5 dice were thrown how many times? 96 times. So at that time what happens here? So since five dice were thrown 96 times, so what happens here? Therefore 96 times p of x, so which will consider a capital F of x. That is, capital F of x is nothing but 96 into 5cx 0.5 raised to x 0.5 raised to 5 minus x. We'll use this formula to get what your theoretical frequencies. So here this x will take, means 5 dice means it will start from x equal to 0. What is the theoretical value? So this is the formula for theoretical frequency now. So when x is 0, what is the answer of f of 0? When x is 1, what is f of 1? When x is 2, then what is f of 2? Similarly f of 3, f of 4 and f of 5, and we'll see this whatever result we'll get from this respective table. Okay, now we'll put x is equal to 0. We'll see. So f of 0 is equal to 96 into 5c0 0.5 raised to 0 0.5 raised to 5 minus 0. So after simplification we'll get the answer 3. Next, f of 1 is equal to 96 into 5c1 0.5 raised to 1 0.5 raised to 5 minus 1, and result will be what here? If you calculate, so you prepare a formula in the calculator: 96 into 5cx into 0.5 raised to x into 0.5 raised to 5 minus x. So after preparing a formula, calc option, so replace the value of x. When x is 0, answer is 3. So I have taken when x is 1, calc option, when x is 1, so answer is 15. So mention here 15. Similarly, when f of 2 is equal to 96 into 5c2 0.1 raised to 1 raised to 2 0.5 raised to 5 minus 2, so we'll check the answer directly. Then f of 3 is equal to 96 into 5c3 0.5 raised to 3 0.5 raised to 5 minus 3. What is the result? We'll check. Then f of 4 is equal to 96 into 5c3 0.5 raised to 4, sorry, 5c4 0.5 raised to 4 0.5 raised to 5 minus 4 equal to, and last one, f of 5 is equal to 96 into 5c5 0.5 raised to 5 0.5 raised to 5 minus 5. We'll go one by one. When x is 2, so result is 30. When x is 3, result is 30 again. When x is 4, it is 15. When x is 5, it is 3. So these are the result what we got. These all results are nothing but theoretical frequency. So therefore the expected, that is we call it is expected as theoretical frequency are 3, 15, 30, 30, 15, 3. So this is the required solution here. Next question is, 4 coins are tossed 100 times and the following result were obtained. Fit a binomial distribution for the data and calculate the theoretical frequencies. So number of head 0, 1, 2, 3, 4, these are the 4 coins they have tossed. So frequency is given respectively. So 4 coins. So here by binomial distribution, so p of x is given by ncx p raised to x q raised to n minus x. So we need to find the value of n. So n is 4 here. So p we need to find. So here I will use one more way. So actually here they have given coins. So in the coin we have either head or tail. So probability of getting head is 1 by 2 and getting tail is also 1 by 2, or p is nothing but if p get 1 by 2 we can find what here q easily. So one more way of finding p is, I will use the formula here as, so number of head, this is the x values and this is f value. So I will mention here, this is what here, this is x value and this is f frequency. I am mentioning this is x and this is f. Now we know that generally the mean is given by, so mean is nothing but mu. General formula, it is summation of f into x divided by summation of f, which is nothing but we need to add these all. Summation 0 into 5 is 0 plus 1 into 29 is 29 plus 2 into 36 is 72 plus 3 into 25 is 75 plus 4 into 5 is 20 divided by summation of f. If you add 5, 29 plus 36 plus 25 plus 5, you will get 100. So on calculation it will become 196 divided by 100, which is nothing but 1.96. So therefore according to binomial distribution, mu is nothing but np, which is nothing but we got answer how much here 1.96. so which implies np is equal to 1.96 or p is nothing but 1.96 divided by n. 1.96 divided by n is 4 here. So 196 1.96 divided by 4, the resultant will be how much here? It is 0.49. So if you see, it is equivalent to 0.5 only. Okay, so if you go directly, the number of the probability of getting head is also 1 by 2. 1 by 2 is nothing but 0.5, or else approximately it is. So I have shown you in this way also you can calculate the value of p. Okay, now so once we got p, so p is how much here? 0.49. so therefore q is nothing but 1 minus p, which is nothing but how much here? So q is equal to 1 minus 0.49. so we'll get 1 minus 0.49 is 0.51. so this is the value of q. So we got p, q. We'll go back to p of x formula. So therefore P of x is equal to 4cx. P is 0.49 raised to x. Q is 0.51 raised to 4 minus x. So this is our P of x. But we know that, so they have tossed the coin, means how many times? 100 times. So therefore since 4 coins were tossed 100 times, we have capital F of x is equal to 100 into P of x, that is 100 into 4cx, 0.49 raised to x, 0.51 raised to 4 minus x. This is our capital F of x. So f of x, theoretical frequency we are finding, where here x will take the value 0, 1, 2, 3 and 4. So f of 0, will calculate the answer. So if you apply f of 0 here, so we'll get the answer as, if you apply here, so directly you can frame this formula in the calculator. You apply this formula in the calculator as like that. Hundred into 4 c alpha x into bracket 0.49 raised to alpha x into cursor here into bracket 0.51 raised to 4 minus alpha x, calc option. Okay, now when x is 0, we'll getting the answer how much here? 6.76, which is, I will round up as 7 because I want whole number. Next, f of 1, calc option, when x is 1, so result is 25.99, which is equivalent to 26. Next, f of 2, when x is 2, it will be 37.47, which is equivalent to 37 itself, because you just see the first decimal number. Next, f of 3, when x is 3, we'll get it is 24.00, which is equivalent to 24. And last one, when f of 4, it will be 5.76, which is equivalent to 6. If you add these value, this you will get exactly equivalent to what here your in the given frequency it will be matched. So therefore the required theoretical frequency are 7, 26, 37, 24 and 6. So in this way you have to complete the problem. So these kind of examples are important. Thank you.